Hello, welcome to my YouTube channel. In this video, we're gonna look a few questions from this paper, October-November 2019, Pure Mathematics 1. So let's have a look on question number 1. It says find the term independent of x in the expansion of 2x plus 1 over 4x squared whole to the power of 6. So the term independent of x, where we cannot have x anymore, so there are different ways, but like what you can do over here, let's say we'll just like try to write the powers, because here if the numerator power of x and here the denominator power of x, if they meet the same, so that's mean we can cancel out with each other and then we can get the term independent of x. So right over here, let's say, so the first one, we start with the highest power as a 6, and the second one is starting with 0, then plus. So for this one it should be 5 and then 1 plus 4, 2 plus 3, 3 over here. So I mean we can continue in this way. If you look over here, so this has 6 0, this will be having a 5 1, and then this is 4 2. So here if we have 4, so 2x is the first term over here, and the second term is 1 over 4x squared. So now x to the power 4 over x squared times to the power of 2, so this will give you again x to the power of 4. So since you know this is 6c0, 6c1, and this is 6c2, so that means this is the term from where we can get the independent of x term. So 6c2, 2x to the power of 4, and 1 over 4x square whole to the power of 2. So now from here we can calculate what is 6c2. So 6c2 is 15, and then if you expand this, so 2 to the power 4, which is 16, x to the power 4 times 1 over 4 square is 16, and then x to the power of 4. So now over here we can see like they are multiplying with each other, so 15 times 16x to the power 4 over 16x to the power 4, so they will cancel out with each other, so we will get the term independent of x, which is equal to 15. Okay, so let's have a look in question number 2 now. This question, it says an increasing function f is defined for x greater than n, where n is an integer and it is given that f dash of x, so f dash of x is equal to x squared minus 6x plus 8. So find the least possible value for n. Since it says it is an increasing function, so if it is increasing function, so as I remember, the first derivative need to be greater than 0. So we can set this equation greater than 0 and we can solve over here for as a quadratic equation. So the factors for this will be x minus 2 and x minus 4, so they together they make 6. If we add them together and if we multiply, they will give us 8, positive 8. So that means there are two values, x is equal to 2 or x is equal to 4 we can get over here. Now it says it's an increasing function and f is defined for x greater than n. So where n is an integer, it is given that the first derivative is equal to x squared minus 6x plus 8. So find the least possible value of n. So from here we can see over here, so the least value is 4. In order to find this one, you can even sketch, and you can see over here. So the least possible value for n is 4. Let's have a look on the next question. It says question number 3, the line y is equal to ax plus b is a tangent to the curve y is equal to 2x cubed minus 5x squared minus 3x plus c, and this is tangent at a point 2, 6. So find the values of the constant a, b, and c. And we know this line y is equal to ax plus b is a tangent to this curve. So now, since here, I mean, it says it's a tangent, so we can differentiate the curve. So dy by dx is equal to 6x squared minus 10x minus 3. I mean, we apply the power rule over here, and then it says it's a tangent to the curve at point 26. So if we plug over here the coordinate, so dy by dx at x is equal to 2, so 6 times 2 square minus 10 times 2 minus 3. So this will be how much? 24 minus 20 minus 3. So that means this will be equal to 1. So since from here in 1 we found this as a 1, so if you look into this one, so this is a gradient. So if you compare with the actual equation, like the equation of a line which is tangent to this curve, so that's mean from here we can find this is the gradient mx plus b. So that's mean this will give us a is equal to 1. So if we know a is 1, so from here if we continue from this equation, so y is equal to x plus b. So now again we can input this point into this equation. So if we will insert these points, so 6 is equal to 2 plus b, so which means b is equal to 4. So once we found b is equal to 4, now we need to solve for c. So in order to solve for c, we need this equation. So let me write over here. So y is equal to 2x cubed minus 5x squared minus 3x plus c, and the point is 2, 6. So we can plug the values. So y is 6 and x is 2. So that means this is 6, and then 2 to the power 3 is 8, 8 times 2 is 16, minus 20 minus 6 plus c. So if we simplify this one, so c must be equal to 16 over here. Okay, so now let's see the next question. In question number 4, it says a runner who is training for a long distance race plans to run increasing distance each day for 21 days. She will run x kilometer on day 1. So that's mean the first term we are having, that is a1, which is x kilometer, and then it says on each subsequent day she will increase the distance by 10% of the previous day's distance. So here, in order to find, because if it is 10%, so this is referring to the geometric sequence, so the ratio, so it says 10% of the previous. So initially we will consider we have 100% plus 10% of that, because it will increase every day. So that's mean this will be 110%, and if you convert this into decimal, so this will be 1.1. so that's mean the common ratio is 1.1 over here. Then it says on day 21 she will run 20 kilometer. So now over here, if it is running 20 kilometers, so the final distance is given to us. So a21 is equal to 20 kilometer. So now you remember geometric sequence. So the nth term for geometric sequence is an is equal to a1 r to the power of n minus 1, or sometime we use u. So an, so here it's a21 is equal to a1 r to the power 21 minus 1. So a21 is what, 20 kilometer, and a1 is x kilometer, and then r is 1.1 to the power of 20. So if we rearrange this, because we need to know the distance, so this will be 20 divided by 1.1 to the power of 20. So if you just simplify this, so this will give you x is equal to, so this will be x is equal to 3 kilometer. Then it says find the total distance she runs over the 21 days. So now it's talking about sum. So we need to use the sum formula. So Sn for geometric sequence must be A1. And since you remember, like, our common ratio is 1.1, so it's more than 1. So we will do A1 r to the power n minus 1 over r minus 1. So we will substitute the values because we are looking for S21. So A1 is 3 kilometer and R is 1.1 to the power of 21 minus 1 over 1.1 minus 1. Simply use a calculator. So S21 will be equal to 100. So 192 kilometer. So that is the distance, total distance she runs over the 21 days. So the rest of the question, I'll prepare another video. In this video I'll stop over here. Hope so far until question number 4 it's clear. Thanks for watching Math Genius.